Today we're working in our unit on fraction operations, and we're going to be focusing on handout number 2. So yesterday we talked about factors and multiples, and today we're going to use that knowledge to help us do adding and subtracting of fractions. So let's look here at these examples to help us find the least common denominator. We're going to use some of our knowledge from yesterday. So this says determine the least common denominator for each set of fractions, but do not solve. So it doesn't want us to solve the problem, it just wants us to find the least common denominator. Many times you'll see least common denominator abbreviated as the letters L, C, D. Yesterday we talked about factors and multiples. And the method that you would use to find the least common denominator is to look at the denominators or the bottom number of each fraction, and you would find the least common multiple. That's the least common denominator. So some students like to write out the two denominators and look for the least common multiple. So remember, multiple means multiply. So I'm going to say 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6. And then I'm going to look at my multiples of 4 until I find one they have in common. 4 times 1, 4 times 2, 4 times 3. I see they both have 12 in common. It's the smallest multiple they have in common. So therefore my LCD, or my least common denominator, would be 12. Go ahead and do the same thing for problem number 2. Find the least common denominator for these two numbers. Pause the video and then come back and check your work. Let's look at how to find the least common denominator for our two fractions, 4/7 and 1/6. So our denominators of our fraction are 7 and 6. I'm going to write out my multiples of each number to find a number they both have in common. 7 times 1 is 7, 7 times 2, 7 times 3, 7 times 4, 7 times 5, 7 times 6, 7 times 7. Let's write out my multiples of 6. 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, and 6 times 7. So I see that they both have 42 in common. So the least common denominator of 7 and 6 is 42. Now you might already be able to figure out these least common denominators from your prior knowledge of fractions just in your mind. In your mind you might already be thinking of the multiples, and sometimes you can find those without writing all of those out. But for our examples, I'm going to write them out to show you what mathematically is happening. In number 3, they give us 3 fractions. So we use the same method, but we just find the multiples of all 3 numbers or all 3 denominators instead of 2. So I have 6, 12, and 8. So my multiples of 6, 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6. I'm going to stop there and see if I can find one that all 3 have in common. 12 times 1, but I wouldn't stop there because I know that a multiple of 8 would not be 12. 12 times 2 is 24. So I do see 24, and I feel like I remember that a multiple of 8 is 24. So 8 times 1, 8 times 2, and 8 times 3 is 24. So I see that the least common denominator of all 3 of these fractions is 24. So again, multiples are how we find our least common denominator. So now let's look at the steps for adding and subtracting fractions. This is the 4-step process that you've probably heard before, but it's a good time to go back and refresh our memory. So this says that fractions and mixed numbers can be added and subtracted by following these steps. Step number 1, find the least common denominator. Also known as the LCD of the fraction. So step 1, find the least common denominator of the fractions. Number 2, rename each fraction. And I'm going to show you how to do that down below. Number 3, add or subtract the numerator. So you're only going to add the top number, the numerator of both fractions, and you leave the denominator the same. Step 4 is to regroup and to simplify. So let's look at a problem going through these 4 steps. So number 4, 3/5 plus 1/3. So step 1 tells me to find the least common denominator of the fractions. So if I remember from 1, 2, and 3, we did that by listing out the multiples of our numbers. So let's list out some multiples of 5 and 3. 5 times 1, 5 times 2, 5 times 3. I think I remember 15 being a multiple of 3. Let's check. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. Yep. So that means my least common denominator is going to be 15. I like to write my fractions one on top of the other in order to add or subtract them. So we just did step number 1 and found the least common denominator. Step 2 tells us that we have to rename each fraction. So that means next to each problem, I'm going to write my new fraction denominator of 15, and now I have to regroup each fraction. I have to convert and find an equivalent fraction for each one of these. So I have to think to myself, 5 times something was 15. Well, I know that 5 times 3 was 15. And whatever I do when I'm converting my denominator, I have to do the same process for my numerator. So 3 times 3 I know is 9. Now I do the same process to rename my bottom fraction. 3 times something is 15. And I know that it's 3 times 5. So 3 times 5 is 15, and whatever I do to the denominator, I do the same thing to the numerator. So 1 times 5 is 5. Now I have 2 fractions with the same denominator, so I know I can go ahead and add. Step number 3 tells me to add or subtract the numerator. So I'm only adding these top numbers, 9 plus 5, which I know is 14, and then the directions tell me to leave the denominator the same, so I leave it as 15. Now I look at both of my numbers, 14 and 15, and I think, do they have anything in common? This is where I use my greatest common factors. And I know my factors of 14 are something like 7 times 2, and I know that 15 doesn't have a factor of 2, and it also doesn't have a factor of 7. So therefore that means this fraction is already simplified. So my answer to 3/5 plus 1/3 is 14/5. Now I want you to try the same process with problem number 5. The only difference is that you're going to be subtracting instead of adding. So don't forget to do the right operation. Pause the video and solve the problem, and then come back and look and check your work. All right, now I'm going to find the multiples of 8 and 4, my denominators. So I know that 4 times 1 is 4, 4 times 2 is 8, and I know that 8 is 8 times 1. So my LCD is going to be 8. Now I like to set my fractions up vertically, and I'm going to do step number 2, rename each fraction. Well, I don't need to rename this top one because it already has a denominator of 8. And the only thing I'd be doing is multiplying the numerator and the denominator by 1. So let's look at our bottom numbers, 1/4. So 4 times something is 8. And I know that that's 2. So 4 times 2 is 8, and 1 times 2 is 2. So now I've done step 2 and I've renamed each fraction. So now I'm going to move to step 3. I know that if I subtract 3 minus 2, I get 1. And then I know I leave my denominator alone. I get 1/8. I don't need to regroup the fractions because my numerator is not bigger than my denominator. And I know that there's no way for me to simplify because 1 is a prime number. So 3/8 minus 1/4 equals 1/8. Now let's look at an example of number 6. So number 6, I need to find my least common denominator. of 2 and 6. So 2, 4, 6, and I know that 6 obviously is a common factor of multiple of 6. So now let's set up our problem. Now we'll do step number 2 and rename each fraction. I don't need to do anything to my bottom number, but I do need to rename my top fraction. So 2 times something is 6. That something is 3. So 1 times 3 is 6 as well. Now I'm going to add my fractions. I only add the numerator. So 3 plus 5 is 8. And my denominator stays the same of 6. This is what's called an improper fraction. Anytime the numerator is bigger than the denominator, this is an improper fraction and I can't leave it like this. So in order to simplify, I take the numerator, 8 in this case, and I divide it by my denominator. And I do the steps for long division. So 6 goes into 8 one time. 1 times 6 is 6. 8 minus 6 is 2. And I don't have anything left to bring down, so this 2 becomes my fraction, my numerator, and 6 stays my denominator. So I do get 1 and 2/6, but I can simplify the fraction part because I know that a factor they both have in common is 2. So if I divide 2 by 2, I get 1, and if I divide 6 by 2, I get 3. So the simplified answer to this is really 1 and 1/3. So I hope this is review to help you out from years past. So I want you to try number 7 and number 8, and then come back and we'll see how you did. All right, let's look at number 7. So anytime we have mixed numbers, we have to rename them into improper fractions before we can add or subtract. So I like to take and do improper fractions first and then subtract them. Some people like to just leave them as fractions like this and only convert the fraction. So you can do it either way that you probably have learned in years past. Either way works. So in order to convert this into an improper fraction, I multiply the denominator times the whole number. So 2 times 5 is 10. And then I take that product and I add it to the numerator. So 10 plus 2 is 12. So I'm going to take 12/5 and I'm going to subtract. Now we need to figure this one out. 3 times 1 is 3 plus 1 more is 4. So really what I'm going to be doing here is taking 12/5 and subtracting 4/3 from it. Step 1 tells me to find my least common denominator. So I know in my mind that if I wrote these out, because I already did this up above, my new denominator is going to be 15. So I'm going to rewrite my fractions vertically, convert them so I can subtract. So my new denominator will be 15. So I found my least common denominator. Now I'm going to rename my fractions. So 3 times 5 is 15. And whatever I do to the denominator, I do the same thing to the numerator. 4 times 5 is 20. 5 times something is 15, and that something is 3. 12 times 3 is 36. Now I've renamed the fractions. Now I'm going to add and subtract. So I know I need to subtract in this problem. I always circle my operation so I don't accidentally do the wrong one. Now I'm going to subtract my numerator. So 36 minus 20, I know, is 16. And then I leave my denominator alone. I know I cannot leave this improper fraction. So I'm going to take and I'm going to divide my numerator by my denominator. So 15 goes into 16 one time. 1 times 15 is 15. And when I subtract 16 minus 15, I get 1. The remainder is my numerator, and 15 stays as my denominator. I know that I can't simplify this, so my answer is 1 and 1/15. Now let me show you how to leave your number as a mixed number and just convert the fractions and follow the same steps. This might be a method that you've used in other years. So again, I'm going to write my fractions vertically. And now I'm going to find the least common denominator of 2 and 3. If I wrote out my multiples, I would find that my least common denominator is going to be 6. So 3 times something is 6, and that something is 2. So I'm going to multiply the numerator times the same. 1 times 2 is 2. 2 times 3 is 6, and I'm going to do the same thing to the numerator by multiplying 1 times 3, and I'm going to get 3. So I found the least common denominator. I've renamed the fractions. Now I need to add or subtract. In this case, I'm adding. So I add the numerator. 3 plus 2 is 5, and my denominator stays the same. I added the fractions. Now I need to add or subtract the whole number. So I look here at the whole numbers, and 4 plus 1 is 5. In this case, I don't need to regroup because my numerator is not bigger than my denominator. And I don't need to simplify because 5 is a prime number, and I know I can't divide 6 evenly by 5. So that means my fraction is simplified all the way. That's how you add and subtract fractions. Now let's turn it over to the back, and let's regroup some mixed numbers. So this should be more review of what you've done in years past, but let's walk through the steps. So whenever we're regrouping mixed numbers, we usually need to regroup when we're subtracting. Because in subtraction, when we think about a regrouping problem in years past, it happens when you have a number on the top that is smaller than your number on the bottom. And that's what's going to happen in subtraction of fractions problems, where you're going to need to regroup. So let's look at the steps. So when I'm subtracting mixed numbers, you may need to regroup the whole number into what we call its fractional parts. All that means is that you're going to look at the denominator of your fraction, and you're going to figure out how many parts you have. So I like to think about it like a candy bar. I could have a whole candy bar, but if I've ever looked at one of those Hershey bars, they have a bunch of same-sized pieces. So I could also take my whole candy bar and break it up into all its parts and count how many pieces I have. So I could have one whole candy bar, but in this example, if I broke it up, I would have fourths. I would have 4 out of the 4 to equal one whole. Let's look at these examples here. So one whole, if I had eighths, would equal 8 parts. If I had one whole, I would have 8 eighths. If I have one whole and I have fifths, I know that I would have 5 fifths. If I had 2 wholes and I wanted to borrow one, that would leave me with 1 whole and 3 thirds. So let's look at some examples of regrouping with a whole number. If I look at number 9, I see that I have 1 minus 2 sevenths. I like to write it this way because my 1 is a whole number, but I'm going to have to regroup because I have 0 in my fraction. If I have 0, I can't take something away. So this is where I would need to regroup. That means I'm going to borrow from my whole number, and if I borrow 1, I'm going to be left with 0. But I'm going to look at this denominator of this fraction to tell me how many parts I'm breaking it up into. And I know that if I had 7 sevenths, that would equal 1 whole. My fraction denominators are the same, so now I can subtract. I subtract my numerator, 7 minus 2, and I get 5, and then I leave my denominator alone. I can't simplify this fraction any because each number is a prime number. So 1 minus 2 sevenths equals 5 sevenths. Why don't you try number 10? Pause the video and then come back and check your work. All right, in example number 10, I have 2 minus 3 tenths. When I look at 2, it's a whole number, which means it has no fractional parts. So that means I need to regroup because I can't have 0 and take 3 tenths away from that. I'm going to borrow 1 from the 2. That'll leave me 1 whole. And then I took the other 1 and I broke it up into its parts. So I look at the denominator of the other fraction, and I know that if I had 10 out of the 10 parts, that would equal 1 whole. So 10 minus 3, subtracting the numerator, 10 minus 3 is 7, and then I leave my denominator the same, of tenths. Now I can subtract the whole numbers. So 1 minus 0 equals 1. 7 is a prime number, so I can't simplify this fraction. So 2 minus 3 tenths is equal to 1 and 7 tenths. You try number 11 and then come back and check. All right, here we go. 5 minus 3 twentieths. So when I have a whole number, I don't have any fraction, and I know I can't take 0 and subtract. So I'm going to cross out my 5, make it a 4. I'm regrouping, and the 20 tells me I'm going to have 20 out of 20 parts to make one whole. Now I'm going to subtract. So 20 minus 3 is 17, and then I leave my denominator alone. Now I'm going to subtract my whole number. So 4 minus 0 equals 4. 20 is made up of factors, but 17 is a prime number. So in this case, I know I can't simplify. So my answer to 5 minus 3 twentieths is 4 and 17 twentieths. Let's go ahead and look at number 12, because this one's going to be a little bit different. In number 12, I have a mixed number, 2 and 1/4, and I'm going to be subtracting 3/4 from that. So both fractions have the same denominator, but if I have 1/4, if I have 1, I can't subtract 3 from that. So that means I need to regroup. I'm going to go to my whole number of 2 and borrow 1. This denominator tells me how many parts that I'm borrowing, and I need to add that to the parts that I already have. So I'm going to add 4/4 to the 1/4 that I already have and add the numerator. 1 plus 4 is 5, and then I leave my denominator alone. So now I have a big enough fraction in my top number to subtract 3 from it. So 5 minus 3 is 2, and I leave my denominator alone. Now I can take and subtract my whole number. 1 minus 0 is 1. I need to simplify my fraction here by dividing both the numerator and denominator by the factor they have in common of 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So my simplified answer will be 1 and 1/2. Now let's look at number 13 before you try number 14 on your own. So I have 7 and 1/8, and I'm subtracting 2 and 3/4 from that. So before I subtract, I'm going to have to find a common denominator. I have 8 and 4. So my common denominator I know is going to be 8. I don't need to convert my top fraction because it's already 8s, but I do to my bottom fraction. So I know 4 times 2 is 8, and 3 times 2 is 6. When both fractions have a common denominator, I see that my top fraction is smaller than my bottom fraction. So that means I'm going to need to regroup. I'm going to borrow 1 from my 7, so my 7 becomes a 6, and I'm going to add the fractional parts to the number I already have. So this 8 tells me that I have 8/8 in order to have one whole. So 1 plus 8 is 9, and then my denominator stays the same. Now I have 9/8, and I'm going to subtract 6/8 from that. So 9 minus 6 is 3, and I leave my denominator alone. 6 minus 2, now I subtract my whole numbers, is 4. 3 is not a factor of 8, so I know my final simplified answer is 4 and 3/8. Go ahead and pause the video and try number 14 on your own. Then come back and check your work. All right, here we go. 5 and 1/6 minus 1 and 2/3. So the first thing I need to do is find a common denominator of both fractions. Looking at the denominators, I know that the least common multiple is 6. I won't need to convert the top fraction because it already has a denominator of 6, but I do need to convert the bottom fraction. So 3 times 2 is 6, and 2 times 2 is 4. Since I'm subtracting, I can't take 1 minus 4 because that would be a negative number, and I can't do that. So here I need to regroup. You should have crossed out the 5 and made it a 4, and then added the fractional parts to it. When I look at the denominator, I see 6, so I know I'm going to be adding 6/6 to the number I already have. 1 plus 6 is 7, and my denominator stays the same of 6. Now I have 7/6 and 4/6, and I know I can subtract. 7 minus 4 is 3, and my denominator stays the same. Now I subtract my whole number, 4 minus 1, and that equals 3. When I look at my fraction, I need to simplify. I see that 3 is a common factor of both 3 and 6. So to simplify, I'm going to divide both the numerator and the denominator by 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2. That means my final answer, simplified, is 3 1/2. Now let's look at a couple of word problems. Number 15 says, on Wednesday, Leah rode the city bus for 3 1/2 miles. Let's underline Wednesday and 3 1/2 miles. On Thursday, she rode the bus for 4 1/2 miles. How much farther did Leah ride the bus on Thursday than on Wednesday? So if I'm trying to find the difference between these two distances, I know that I'm going to be subtracting. Anytime I subtract, my larger number needs to go first. So I'm going to be taking 4 1/2, and I'm going to be subtracting 3 1/2 from it. I'm going to use my same process that I've used for these other fractions to solve this. So 4 1/2 minus 3 1/2. I know I need to find a common denominator first. So my denominator is going to be 4 for both fractions because that's the smallest multiple they have in common. So 2 times 2 is 4, and I know whatever I do to the denominator, I do to the numerator, and I get 2. I don't need to convert my top fraction because it already has a denominator of 4. So I know that I cannot take 1 and subtract 2 from it, and I'm going to regroup. My 4 is going to become a 3, and my fractional parts are 4/4. 4 plus 1 is 5, and I leave my denominator alone. Now I have 5/4 and my original number of 2/4. Now I can subtract. 5 minus 2 is 3, and 4 as my denominator stays the same. Now if I subtract my whole numbers of 3 minus 3, I get 0. So Leah rode the bus 3/4 miles farther on Thursday than on Wednesday. So the answer to this question is 3/4 of a mile. All right, now let's look at number 16. Number 16 says, the perimeter of the triangle below is 6 feet. What is the missing side length? Called x. So for perimeter, I know that we add up all the sides. And this is telling me that the perimeter equals 6. I know that whatever I'm going to get from this is going to equal 6 feet. They give me 2 sides, and I'm going to use that information to help me figure out my final answer. So in order to figure out x, this is going to be a 2-step problem. I'm going to need to add 1 7/8 and 2 1/2, and whatever I get for my sum, I'm going to need to take and subtract from 6. So here's how we would set that up. I'm going to add 1 7/8 plus 2 1/2. I know to add my fractions, I need a common denominator, and the least common denominator for both is going to be 8. The top fraction already has 8 as a denominator, so I don't need to convert it, but I do to my bottom fraction. 2 times 4 is 8, and then 1 times 4 is 4. Now I have the same denominator, so I can add both fractions. 7 plus 4 is 11 over 8, and if I add my whole numbers, I get 1 plus 2, which is 3. Well, I can't leave this as an improper fraction, so I'm going to convert this. 11 divided by 8, we need to come up with a mixed number. So I know 8 goes into 11 one time. 1 times 8 is 8, and 11 minus 8 is 3. 3 becomes my numerator of my new fraction, and 8 stays my denominator. I'm going to add 1 3/8 plus my original whole number of 3. So that's going to give me 4 3/8. So I already have this distance of my perimeter, which is 4 3/8. Now I'm going to subtract that from the total that I know it should be, which is 6. So this subtraction problem is going to be 6 minus 4 3/8. So now I'm going to be using my regrouping strategy because I don't have a fraction on the top number and I need to in order to subtract. I'm going to cross out my 6 and make it a 5. The fractional part of that one piece is going to equal 8ths because I have 8/8 or 3/8 right here. That means I'm going to have 8/8. Now I have the same denominator, so I can subtract. 8 minus 3 is 5, and I leave my denominator alone, and now I'm going to subtract my whole number. 5 minus 4 is 1. So this side, x, is going to be 1 5/8 feet. So that one was a little more challenging with multiple steps. Tonight for homework, you're going to be doing homework number 2. There's a mixture of all the different things that we've practiced, and there's some word problems. So make sure that you reference your handout to be able to help you solve these problems. And when you come back to class, we'll check them.